Hi everyone, my name is Daniel. I work for Outreach. It's a pleasure to be here with you, see so many fellow Gophers. I would like to talk about Go Generate. Let's start with some quick poll. How many of you know Go Generate? Okay, almost everybody. How many of you use it in daily basis or okay, it's not so many. So probably I can show you something that will be useful for you. So what will be the content of the lecture or talk? We will briefly introduce how GoGenerate works, what it does. We will show or speak about how why to use it and why not to use some other technique for generating code. And we will do some live coding session, the most loved and most hated. So let's see how it works. So first, what is GoGenerate? We can tell that GoGenerate is composed from three parts. So one is the built-in GoGenerate command, which is shipped with the Golang release. Then it's Go generate commands that you can put into your source code. And the last one is the generator itself. We will see what it is and how can we use that. So let's go into code. We have empty Go module. And we can start by directly invoking GoGenerate, and let's see what it does. So it did nothing visible, but what it did under the hood is that it looked for the main package and searched for all files that are in main package and search these files for these magic commands I have showed you, this go generate commands. And if there is some command, it will execute it basically. So let's try that. Let's create a main go, package main. And let's put there some go generate command. And what to put next? Basically, we can put there almost everything. We can try some not working stuff. Let's try what it will do. It will complain that the XXX, it's not a path of some executable. So the first argument of this command, it has to be some valid executable that Go can actually run. So we can put there almost anything, any executable, and pass it some arguments, for example, this XXX. And if we run it, we can see the, is it visible? Okay, maybe I can put it, no. Yeah, but probably better. Yeah, so we can see that it just outputted the result of the echo command. So this way we can execute almost anything. The only limitation is that we cannot do like the full shell scripting here. For example, if I would like to print the environment and then grab something, for example, current directory, it will not be possible because it tries to take it as name of the binary with the slash. So we have to put there some one executable, and everything else has to be parameters. So we can, for example, run bash c, and the rest goes as parameters to bash. And now we can see, now we can see what current directory is it executed in. Okay. But yeah, this is not the intention of GoGenerate to call some echoes or bash commands. It's intended to generate code, right? This is the purpose. So one more thing that it can do is that you can create aliases for these definitions. So you can tell. I will. Yeah. Okay. Good. So I can tell that this first command will be called foo, and the rest is the command. So this is the name of the command. This is the rest. Now it will do nothing because it's just why it's doing something it shouldn't. Maybe 2m or maybe it was not saved. Yeah, it's not doing anything. And now I can execute this alias command multiple times, for example, with different parameters. Yeah. So I can now see that it executed foo with the last parameter different. So yeah. So if I, yeah, basically. Okay, so that's basically how GoGenerate works. And we can here execute some real code generators, for example, protoc, which will generate protofile protocol buffers stubs from protofiles, or we can generate some other like language parser or something. And of course, we can also execute directly our own code. So we can write code that generates more code. And this can repeat. Okay, not do that. Okay. Yeah. Okay, next topic, why to use it? What is the reason to use GoGenerate? Basically, Golang doesn't have much support for some metaprogramming in comparison to Python, Ruby, and other languages. So there are situations that you have to write a lot of repeating code or code that is somehow boilerplate. And we don't like writing duplicate code or boilerplate. So we can use GoGenerate to avoid writing such code. And of course, we don't need to use GoGenerate. We can use some other tools because GoGenerate is basically executor just. So we can use, for example, Makefile to do similar stuff. But GoGenerate brings a little bit more more tools to your hands that you can use and then that are better connected to the Go environment. For example, the GoGenerate is package aware and env aware. So I can show it. What I mean by it. So let's go to some first example. I have here 3 packages. Yeah. So internal package and main with two files. And in every package, I have some Go generate commands. And if I run just plain Go generate, it will execute just the comments, the Go generate commands in the main package. But I can select to run all packages. You can see it goes from main, internal, and package. And I can also put full package name there, which is the difference of makefile, for example, that Go generate gives you. So I can put, for example, this. It will execute the internal package. Okay, and then it has some other nice features. For example, you can tell only to print what it will execute, or even some more debugging output where it tells every command that it will be executed, and then it executes it. Okay. Yeah, and about the environment, as I have shown you before, if we will here print the env, what? Okay, I have to close this one. Yeah. So if I will print environment variables here, then we can see that you have some Go environment variables defined, which can be useful for code generation. Okay. So this was why to use it. And let's go to some real hacking. Will be a little bit difficult example. So if you will lose the string, please raise your voice so I can explain more or something. Okay. So what we have here, we have project where is some protocol buffers definitions for message user. Do you know everybody protocol buffers, or should I? Yeah, okay, almost everybody. Yeah, good. So so we have some message, and let's start to work with it. So I will create some command. Okay. Okay. So let's assume that we are receiving the message over the network. For example, from Kafka, or we are reading it from gRPC or something. So we are getting the user important thing. We don't have the Golang code generated yet. So we have this protocol proto message defined, and here we have the first like real example of some Go generate command. So we are executing protoc. We tell it to generate some Go code and some parameters. So if we run Go generate, it should create us, yes, it should create some Go code. And now we have some user struct defined and some methods for it as well. So we can now import this this code. Yeah. Let's alias it pb as a protobuf. So that's the struct. Let's put some data there. Email. Yeah. Phone, okay. It was ID was there as well. Okay. ID. So, and we would like to log the data we are getting for some later debugging or something. So how to do that? We basically cannot log the whole data because there could be some data that we don't want to log. So we cannot do something like this. So so let's use some other way how to do this. Let's import loggers. What's the name? Yes, Serpsens, thank you. Yeah. Okay. Okay. So we are receiving user, and we would like to use the with fields method to specify what will be logged. User ID. ID, okay. Maybe I will close this one, it's better, yeah. Yeah, so this is somehow working probably. Yeah, maybe there has to be log fields. Yes, now it's working. It's somehow working, but we will probably need to use the same logic on many places. So we will duplicate this logic, and it's probably not very nice. If we add some more fields to the user, we will have to change it on all places, or yeah. So probably not the best idea to do this. Let's add some more logic that will make it more nice. Okay, so let's add some small wrapper for the logging like logic. So I will create package and put log there. Yes. Okay. And what I will try to achieve is to use this new package. Package log. And I would like to introduce method info or a function info there. Received user. and I would like to just put there user. And this could be called on many places, and the logic what to log will be somewhere else. So should now fail, not failing, okay. Yeah. Okay. Yeah, info is not there. Good. So let's introduce the function. So message string, and we would like to introduce some args that will have some interface. So let's call it log Marshall, for example. And we will add it later. So, and this will use logras info message. Okay, so let's import logras. Yeah. Okay, and this log Marshall will be an interface. It will have my one method, and it will return the the log fields for loggers, and the log fields we will define as well. So log fields is map string interface. Okay. And now we can do something like get the fields of the, for example, first argument for simplicity. So Marshall log that should return the fields. We should be now able to call it like this. Okay. Should be, probably. Okay, now we should, yeah, now we see warning that we cannot pass user there because it has no method Marshall log, because we require this this interface. So let's fix it. Let's add file user.go package protobuf, and let's implement this method. Shall log, and it should return fields. Okay. And here we will define, for example, like this, what will be logged. So we have name, email, phone, ID. Let's try. Yeah, yeah, they are missing some dependencies, so I will probably go mod tidy will fix that, but okay. Too many errors. Okay, there is some other. We'll go a bit. Now it should. Where is it? Where are my files? This is weird, a little bit. Okay, yeah, now it's fixed. Okay, so it's a little bit changed, but to have it all working. So now we can see that Logros will output the user ID and username. And we can add some more fields if we would like to. We don't have age. Why do you suggest age? Okay, so we can do phone. Yeah. Phone is not filled. Okay, yeah, we see phone. Okay, so this is a little bit better. We do not write so much duplicate code, but still we would like to improve it a little bit more. So let's start generating some code. We would like to put this information somewhere on some better place where it's like more connected to the original data, and that could be the proto file. How to do that? Protocol buffers allow us to put there some more data. It's called options. There are some predefined options. For example, deprecated. The syntax is a little bit weird, but you will get used to it. And we can also introduce some our own custom options. So let's do that. Let's introduce some custom options. I will go straight to the next step. So we created this log proto, and it's an extension of field options. So we are introducing a new field option with the name key, and the value of it will be string. So we can now use it like this. So this is our option, custom option called log.key. The log is the name of the package. And this is the value where we can specify some data. In this example, we can say under which key we want to log this field. Okay, so we have the data in place, but now how to generate this function, right? This log marshal. Unfortunately, it's not so easy because if I open the generated Go code, yeah, maybe I will close this. You can see that in this generated struct, the data are not present there anywhere. You cannot see the key or something. There is only some protobuf data and some JSON data, how to marshal it to JSON. The data that we put there, this custom option, is only present in this raw descriptor data. So, and the problem is that this struct has different casing than the original proto file. So here is a Pascal case, and in the user proto, it's a snake case. If I introduce some like first name, for example, to be it more visible, how it will create. Yeah, then we can see it's a Pascal case. So it's not, it can be converted together, but it's not one simple operation. But we can use something, yeah, and we need to somehow match these two together to be able to create this this function, because we need both. We need the key, and we also need the name of the field in the struct, in the Go struct. Okay, and we have it on two places, and we need to match it together. And we can do so, for example, by using this struct tag. So in the struct tag, we have some protobuf data, and there is also the original name in the proto file. So let's start some hacking. Let's generate some code. Okay. So I will create another command. Okay, and I will import here the generated code. Yeah. Buff. Okay. And now what can we do with this is there are two types of data for us. One is reflect. So we can use reflect type of, I think. So this will be to work with the struct. And other will be proto reflect descriptor directly on the message. And this will contain the other stuff, the keys and some other data that we'll need. So it would be quite for some time to do this by hand. So I will jump a little bit farther. So this is part of the solution. So let's go through it quickly. So we have array of the messages that we want to process, and we create what we have shown before, this type and proto-reflect descriptors. From the descriptor of the proto file, we can get fields, this fields descriptor, and there will we have this our option we can work with. And with the type, we will iterate through the type, and we can get the tag data. So we take the protobuf data there, and we search for the name there. So now we have the name in the underscore notation, snake case, and we can match it with the descriptor fields. So now we have the field in the struct and field in the descriptor. We can ask if the descriptor has the extension. So basically, if this is defined, or the field, because you can see that not every field has this option. This three doesn't have it. So we check if it's there, and if it is there, then we get the extension data. We convert the value to string, and we store the data in some map, basically. So let's run it. Let's see what it does. Yeah, and we see, you don't see, once again. Okay, so we see the data that we want. So there is the key that we want to log the data, and the name of the field in the Golang struct. And now we can just little bit change the code to create template and to generate real data. So we will create a file called by the name and some suffix, and we will execute a Golang template, which is defined right above here. And it's quite simple. We will just replace one place and do some range over the fields, which is a map. So we have key and value, and that's it. So we will run it. Then we should see the file generated here, and it's there. So we can try to add this option to some other field, generate. Sorry? Key. Thank you. Okay. Yeah, and now we have the phone there as well. So this is somehow useful. Are there some downsides? Of course, there are always some downsides. So I think the biggest downside of generating code like this is that the templates are not very good readable and debuggable. Sometimes it's quite painful to work with them. But otherwise, if the code is really duplicated in many places, it's sometimes better to do some hacking like this and to spare some manual work then. Okay. Yeah, so that was from me. Thank you for your attention. Do you have some questions?
Questions? Thank you for the talk. I have one question about versioning of this generated code. How to do that properly?
Yeah, okay, yeah. I think more topics is connected to this. One is whether to include generated stuff into other commits, for example. My my thought about this is to split it into more commits. So for example, to do normal changes in one commit and do some chore or something commit with the generated code. And of course, you have to commit the changes, the generated code, because you should not generate it in production on somewhere. You always generate it in the local environment, development environment.
Do you generate the code in some CI/CD pipeline, or check if the code is generated properly in some CI/CD pipeline or something like that?
Yeah, I think it's always good to check that the formatting is correct. So to run make ferment or something in the CI and check if it's not changed, and also to run the generator and check if it didn't change the code as well.
Thank you.
You're welcome.
Another questions? Not. Thank you for talk. That was great. And